Now, for the actual cornering and taking turners, it's interesting to track the behavior of the car in the XY plane. But this XY plane, or the representation of the center of the car C, will not give us lots of information as this point C moves along with the car. So we will have to transform the coordinates we obtain from our model, the coordinates in the C frame, to the coordinates in the O frame. So we will have to use the first formula on the left, the actual transform matrix roll pitch yaw, and we will add that to our model. We will add that to our model as I have done here. So what do you see? You see that I took the points, the speed of the car at the center of the car in the x direction, the speed of the car at the center of the car in the y direction, and in the z direction. I all three take them here together. I integrate them, and then I have the actual values of the position of the center of the car in x, y, and z. And I have to do a roll, pitch, yaw rotation to obtain the actual results in a stationary reference frame, and then we have the x result and the y result. X result, we can double click here. I save it as a structure with time, and I do exactly the same for the y result. So, simulating this model would be rather boring as we have a steering angle of 0 degrees, so we adapt the steering angle from 0 degrees to 5 degrees. Now we can run this simulation. If the simulation is done, the results will be in the workspace. And as we can see, we have the x result and the y result. The x result, for instance, is a structure with signals in it. And in the signals we have the values. These are the actual values. So x values are equal to the x result we can copy paste this like that. We also have the y values. It's quite the same, like that. And we can then, of course, plot them together in a figure, which will be valuable to see what the car actually does. And then we obtain this result. So, as we have a steering angle of 5 degrees, we will turn and keep turning as long as that steering angle stays at 5 degrees. So you see here the whole trajectory in the x and y plane. However, we cannot really assess this turning behavior. Is it a circle? Is it an ellipse? We don't need to really see this as we have different limits for the x-axis and the y-axis. And then this is kind of a box, but if we start by moving this around or maybe maximizing it, then this is not really a square anymore. So therefore, we use an additional command which is called pb aspect, and then we can fix the aspect ratio of all our axes. And you see we have 3 axes. We have the z-axis as well. We don't look to the z-axis, we're not interested in it, but still we have a value 1 for the x, value 1 for the y, value 1 for the z, and then they should keep the same ratio. If we run this script, you see a perfect square, and you indeed see a kind of a circular behavior.